Net present value, it captures how much value a project is expected to create. And basically, it's a present value of all the expected cash flows that are relevant for a project. So take all of the cash flows, whether it's for an investment, the cash flow that goes out of your pocket to make these things happen, or project related. Once this thing's happened, the cash flows that either come into you or more that go out of your pocket, take the present value of them, add them up, and that's the NPV. So you got cash flow today, cash flow in 1 year, 2 years, all the way out for however long the project goes, and the project can go forever and ever and ever, potentially, and you add them up. And the rule, so anyway, we've got expected cash flows that we need to discount, and what do we discount them by? The rate that we use to discount them by is the project's cost of capital. And so again, you've got this project that has a certain level of risk. So you look at the financial markets, at stocks and bonds with the same level of risk, and say, what is their expected return? And that's what you use as the cost of capital on this project. And again, the idea is if I've got some money and if I put it in the project, then I'm missing out on the opportunity to invest in these stocks and bonds that have a certain level of risk, and I'm missing out on the potential for that expected return, and so we want to incorporate it in the analysis and we make it the discount rate. And so again, as it says here, a riskier project would have a higher cost of capital because the level of risk associated with the project would be higher. So you compare it to stocks and bonds that have a higher risk, and stocks and bonds with a higher risk will have a higher expected return. So what is the rule? The rule is to accept investments in projects that have positive NPV. And here's the idea. The NPV captures the present value of all expected cash flows. So you can think of it as, the present value of the cash that goes out plus the present value of the cash that goes in. Well, if NPV is positive, then the magnitude of the cash that goes in would be greater than the present value of the magnitude of the present value of the cash that goes out. And that is a good situation. If what I'm getting, what's coming into me, has more value than what I'm taking out of my pocket, then that's value enhancing. That's positive NPV. Negative NPV is just the opposite. It means that the value of what's going out is greater in magnitude than the value of what's coming in. That doesn't make sense. Why would I spend, $100,000 on a project that's going to produce benefits to me that are only $80,000? I'm better off taking the $100,000, finding stocks and bonds that are just as risky as the project, and buying those. If the NPV is equal to 0, then I'm indifferent because the value of what's coming out of my pocket is equal to the value of what's coming into my pocket. That's the NPV rule. So I laid it out in 4 easy steps. Number 1, what are the expected cash flows? And again, when we embark on a project, we don't know what's going to happen. There's uncertainty, there's unpredictability. So these expected cash flows are really just a best guess. You really look at all the things that could happen, the likelihood of them happening, roll it all up together and come up with a number. Stick that in the analysis and make a decision based on that. Cost of capital, how risky is the project? Look at stocks and bonds with the same level of risk. What's their expected return? That's your cost of capital. 3, figure out NPV just by taking the present value of all the expected cash flows, and then make your decision. If NPV is positive, then you invest. If NPV is negative, do not invest. And if it's 0, you'd be indifferent. So one of the assumptions you want to make in this class is that the cost of capital is positive unless it's noted as negative or you're given information that it could be negative. You would assume the cost of capital is positive. That's typical. That means that there's some risk, that there's some compensation, and as a result, cost of capital is positive. So let's take a look at an example. You just finished your freshman year. You think there's an opportunity out there that if you spend $165,000 today building up a network of finance tutors, and so you buy equipment and you buy all kinds of stuff like that, you can use that to generate some positive cash flows. And specifically, today you're going to be out 165. In 1 year, you expect to produce 65,000, then 70 in year 2, and 90 in year 3. And one of the standard assumptions is okay, so suppose we have a year, and again, you're doing business throughout the year, bringing in money from people paying for, tutoring services and finance help and things like that. But we assume that all of the cash flow takes place at the end of the year. And it's nice because then it makes it easy to just discount back. We're dealing with full periods at discrete points in time. And so you're not dealing with the fact that the cash is getting generated evenly over the course of the year. And we make this assumption with NPV and IRR. It's pretty standard. What's the discount rate? Well, given the risk of this project, the appropriate cost of capital is 12%. What's the net present value? Should we pursue this based on net present value? Well, we know the cash flows. They're given, the expected cash flows. Cost of capital is 12%. Compute your NPV, and the answer is NPV is positive. We should go ahead and do this. So let's take a look at what we've actually said. So the NPV is $12,900. What does that mean? Well, we put in $165,000 today. We expect 65 in a year, 70 in 2, and 90 in 3. But because those are expected in 1, 2, and 3 years, we need to discount them. In 1 year, we expect 65,000 divided by 1.12. That's equivalent to expecting 58,036 today. 70,000 in 2 years, discounted by 12% per year, is like getting 55,804. 90,000 in 3 years is like getting 64,060. And so this project is a case where we're putting in $165,000 today to create a business that's worth $177,900. So the value of what we're putting in is 165. The value of what we're getting out is 177,900. So we're increasing value, creating value of 12,900. Now one question might be, well, how do we know it's worth 177,900? And the reason is because we're creating a business where we expect 65,000 in a year, 70 in 2, 90 in 3, which has present values of 58,036, 55,804, and 64,060. Add them up, and that's you get 177,900. NPV is positive. Pursue the project. Now, the financial calculator can be real helpful with net present value. So what you want to do is you want to get into the NPV function, and you do that by hitting the apps key and then hitting 1 for finance applications. If for some reason your finance applications aren't on 1, then go to whatever number they are and you can hit enter, hit that. Then, so if you hit that, you'll see a bunch of different finance functions. NPV should be 7. If it's not, it might be a different number. So you can hit 7 or go highlight NPV. It says NPV and it has an open parentheses. And you hit that, and then NPV in the open parentheses appear on the screen. Then you simply want to give the information to the financial calculator so it can compute NPV. And what's the information? It's discount rate and expected cash flows. So you give it the discount rate. And again, it knows it's a discount rate. So, for example, if it was 2.3%, you wouldn't put in 0.023. You'd simply put in 2.3. If the cost of capital was 14.94%, you wouldn't put in 0.1494. You'd put in 14.94. Then, this is really important, a comma. Comma is really important in this function. It tells the calculator it's time for a new argument. You would then put in C0 and then another comma. And now the calculator says, okay, now I want the rest of the cash flows. So you give it the brackets, which you can get by hitting second and then open parentheses. And now the calculator wants the rest of the cash flows. So you just give it, C1, C2, and you separate them all by a comma. So if you had a cash flow of $56,000, you wouldn't enter it as 56,000. If If you did that, it would assume one cash flow was 56, another one was 0, 0, 0. You'd enter it as 5, 6, 0, 0, 0. And you do that until you're done. Then you close the bracket second by hitting second, close parentheses. Then you close the parentheses to tell the calculator, okay, I'm done now giving you all the information to solve for the NPV given the discount rate that you gave it and the expected cash flows that you gave it. You simply hit enter and it will go ahead and give you the net present value. Again, one of the nice things, NPV function, there's no sign convention. If it's a cash outflow, you put it in as negative. If it's a cash inflow, you put it in as positive. And again, we work a lot with conventional cash flows where C0 is negative and the other ones are positive or 0. Does not have to be that way. So in this case, we've got our cash flows, we've got our cost of capital. So we go to the calculator, NPV open parentheses. Cost of capital is 12%. C0 negative 165,000, so negative 165,000. Again, don't forget the commas. Then you got the brackets to say, okay, the rest of the three cash flows, the brackets, close the parentheses, hit enter, and you get the NPV. And so let's just go real quick. So NPV says, hey, let's find the NPV when the cost of capital is 12 and our cash flows are negative 165 at time 0, 65 at time 1, 70 at time 2, and 90 at time 3. So you would accept the project. NPV is positive.